My name is Anton, and I want to start presenting our project of sentiment analysis from English to German language and from Russian to Ukrainian language. So what are the business problems behind our exploration? Many companies want to track the attitude to their products and services. We used for resolving this problem sentiment analysis. It could be made easy when you have large data set and it is balanced. For handling this issue, we use F1 score, which takes misclassifying false positives as negatives and negatives as positives. And our general approach was char-based model because you don't have to store big vocabulary. It handles misspellings, and many languages have similar char characters. So, what experts say? Transfer learning will be the next driver of machine learning. Let's hype a little bit. Johannes.
So we first focused on German and English. And our goal was to improve our results in sentiment analysis. We had
small and unbalanced data in German movie database, and we used machine learning models which were pre-trained on English language. So first we need some data. We had a large English data set and a very small, 10% German data set, and we got this German data set through web scraping via XPath and char. So in order to compare our method with later models we created two baselines. First the English baseline and the German baseline, as you can see here. And we created after this an English CNN model. Here you can see the architecture we use, especially 4 different kernels. And after this we made some specifications for our model, for a transfer learning model. So first we had to change some of the German letters. We have got mutated vowels. You can see here we had to replace them by English words, and we reduced the batch size and put an add-on optimizer, and with the input from before the weights we trained all layers. And so at the end we trained these layers, and we got before having trained we had a F1 score of 65.5%, and after initializing the weight of the pre-trained English model, we could improve our F1 score to 66.9%, which is a good success.
So we had the similar problem for Russian and Ukrainian languages, so the goal was the same. We wanted to improve our results on sentiment analysis, having really small data and balanced data, and we tried to do that using machine learning models pre-trained on Russian language. So more about data. We had a really huge data set of Russian language with really balanced positive and negative reviews, but on the other hand, for Ukrainian language, we had a pretty small data set, and we had only 38% of negative feedback, as you see here. So first, we had to start with baseline as well. Here you can see that we used SEM plus CFIDF for Ukrainian language, and logistic regression-based backwards for Russian baseline. Here are the results: 90%, 95%. So, and then we stick to a convolutional neural network, and here is its architecture. You can see the main layers. So, but we had to process our data as well. So as you could see in German language, we had with those umlaut characters. Here we had specific characters in Ukrainian language, A, E, D, and G. So we just substituted them with Russian characters, as you can see here. Also, we reduced the batch size 4 times, and we changed the learning rate. We reduced it 10 times in Adam Optimizer. And we tried different approaches in training layers, like freezing some layers or not training them, but then we saw that the best score is when we train all the layers. So as you can see, first we as well trained the Russian model, then we initialized weights when we trained on Ukrainian data set, and we had accuracy F1 score of 90.67%, and now we have 91.12. And now our favorite example, you can see the review here. Here is highlighted the words that are mainly contributed mainly, and some more examples which are can show some differences. So here you can see that SVM predicted really badly, because we see that it predicted it as good, but it's really bad if you read it. But see, our CNN predicted it as correctly, but on the other hand, here you see the different case, and maybe this review that illustrates everything the most. Here you see lots of typos. All the rows have lots of typos in the words, and it actually deals with typos pretty well. Okay, it's conclusion. So, sure, we have differences between these languages, English and German, and Ukrainian and Russian. We have differences in alphabet. Sure, the languages are not that similar. We just use that the alphabets are mostly the same. And what is most important, when we use transfer learning, for example, in computer vision, we can stick to more or less generic architecture of neural network. But here, as we tried different layers, different approaches, we saw that all the architectures really are different on different languages. So we really couldn't use the same layers. We tried lots of stuff. We tried to freeze layers and to train the outputs of the last layer on some other classification. Actually didn't work. So these are our best results. Little improvements in German and in Ukrainian. So that's our team. Thank you all. Our supervisor was still sitting here. You can see the code here. Thank you all.
Thank you so much, guys.